NASA's Curiosity rover just found something on Mars that scientists say took their breath away. A field of honeycomb shape stretching as far as the camera can see, and nobody is completely sure how it formed. NASA's next great space telescope just got fueled for launch, and it's arriving 9 months ahead of schedule. 3 astronauts came home after 241 days and 102 million miles in orbit. And SpaceX had one of its busiest weeks yet, including a classified spy satellite launch. This is This Week in Deep Space Digest. On June 19th and 20th, while climbing a Martian valley called Valle Grande on the foothills of Mount Sharp, NASA's Curiosity rover captured a 360-degree panorama that left its own science team stunned. Stretching across the valley floor in every direction was an enormous field of honeycomb-shaped polygon fractures, each one roughly 1.5 to 3 inches across. Curiosity has spotted small isolated patches of this kind of pattern before during its 14 years on Mars, but a field this size has never been seen. Project scientist Ashwin Vasavada described it simply, "This sea of polygons took their breath away." What makes it even stranger is that the honeycomb pattern doesn't just cover flat ground, it wraps around the vertical sides of a 20-foot sand-capped butte nicknamed Miraflores. Flat terrain and vertical rock face showing the same fracture pattern means whatever caused this affected the entire area uniformly, which makes it much harder to pin down a single cause. Scientists have 3 working theories, and figuring out which one is correct has real implications for whether this valley once held surface water. The first is surface desiccation, simple mud cracking. Fine sediment, once saturated by an ancient lake, dries and contracts under the Martian sun. Repeated wet-dry cycles over thousands of years naturally form these hexagonal, Y-shaped junctions. If this is the cause, it directly points to ancient surface water. The second is thermal contraction cracking. Gale crater swings roughly 180 degrees Fahrenheit between day and night. Extreme temperature shifts alone can fracture ground into polygons without any water involved at all, similar to ice wedge polygons found in Earth's Arctic tundra. The third is burial compression, sediment buried under thousands of feet of rock over millions of years, building internal pressure that squeezes out trapped moisture and fractures the material as it dries. To figure out which theory is correct, Curiosity is deploying its full onboard laboratory. The ChemCam instrument fires a laser at targets up to 23 feet away, vaporizing tiny amounts of rock and reading the chemical elements in the resulting plasma. The APXS instrument measures elemental chemistry up close, and the MAHLI camera captures extreme close-up images of the ridges themselves. If the rover finds soluble salts or sulfates concentrated on the ridges, that points to surface water evaporation. Calcium sulfate veins would suggest deep groundwater burial instead, and a lack of any soluble mineral enrichment at all would point toward the water-free thermal contraction theory. And just to make things stranger, scattered across this light-toned polygon field are dark-toned pebbles and cobbles that don't match the surrounding rock at all. Scientists aren't sure yet if these are fragments that eroded down from higher up the mountain, debris blasted in from a distant impact, or even iron-nickel meteorites that fell from space and landed directly on the Martian surface. Curiosity has been on Mars for 14 years now, since its dramatic sky crane landing in August 2012. It's already confirmed ancient lakes and rivers, found pure sulfur crystals, and detected complex organic molecules that are precursors to RNA and DNA. This sea of polygons is the latest piece in a puzzle that's been building for over a decade: how long liquid water actually persisted on Mars, and whether the planet was ever truly habitable. NASA's next flagship space telescope just passed a major pre-launch milestone, and unlike almost every other big NASA mission in recent memory, it's actually ahead of schedule. On July 25th, technicians wearing full-scape protective suits loaded 290 gallons of hydrazine propellant into the Nancy Grace Roman Space Telescope at Kennedy Space Center. Hydrazine is highly toxic and unstable, which is exactly why the suits were necessary, but it's also exceptionally efficient fuel, and this fueling milestone means Roman is on track for its launch window on August 30th. The telescope is named for Dr. Nancy Grace Roman, NASA's first chief of astronomy and widely known as the mother of the Hubble Space Telescope. Roman has survived 4 separate cancellation attempts between 2018 and 2025 before finally being protected under NASA's $24.4 billion budget. It carries a $4.3 billion price tag, and it will launch aboard a SpaceX Falcon Heavy from the same pad that sent astronauts to the Moon, Launch Complex 39A. Roman carries a 2.4-meter primary mirror, the same size as Hubble's, and actually repurposed from a donated National Reconnaissance Office surveillance telescope. But its real power is its camera. The wide-field instrument is a 300.8 megapixel sensor with a field of view 100 times larger than Hubble's and 50 times wider than James Webb's. To put that field of view in perspective, Roman will be able to survey the entire Milky Way galaxy in a single month. Hubble would need roughly a century to do the same job. Roman will also carry the first active space coronagraph ever built, an instrument using over 2,300 tiny piezoelectric actuators to reshape its mirror in real time and block out starlight with a contrast ratio of 1 part in a billion. This is a technology demonstrator, laying the groundwork for a future observatory that could directly photograph Earth-like planets and search them for signs of life. Roman is headed to the Sun-Earth Lagrange Point 2, about 1 million miles from Earth, where it will share a cosmic neighborhood with James Webb. Its primary mission is 5 years, but it carries enough fuel for 10, and unlike most space telescopes, it's actually designed to be refuelable in the future. The data output alone is staggering. Roman will produce over 500 terabytes a year, more than Hubble generated across its entire 35-year history. 2 major surveys will use all that data: an exoplanet census monitoring 200 million stars to find thousands of new worlds, and a dark energy and dark matter mapping project observing roughly 1 billion galaxies to decode the expansion history of the universe itself. On July 26th, 3 people came home after 8 months in space, and for 2 of them, it was the first time they'd ever left Earth. NASA astronaut Chris Williams, alongside Roscosmos cosmonauts Sergei Kud-Sverchkov and Sergei Mikheyev, landed safely in Kazakhstan aboard Soyuz MS-28 after a 241-day mission. The trio had launched all the way back on November 27, 2025, and in that time they completed 3,856 orbits of Earth and traveled more than 102 million miles. It was the first spaceflight ever for both Williams and Mikheyev. After 8 months of weightlessness, simply standing up again is a genuine physical challenge: bone density loss, muscle weakness, disrupted coordination. Recovery teams pulled the crew from the capsule, gave them initial medical checks in reclining chairs right there on the step, and in a nice touch, handed them fresh fruit and personalized Russian matryoshka dolls before flying them onward for rehabilitation. And SpaceX simply did not slow down this week. On July 30th at 3:10 in the morning, a Falcon 9 launched the classified NROL-95 mission for the National Reconnaissance Office from Cape Canaveral. Analysts tracking the satellite quickly identified it as USA-619, part of the Naval Ocean Surveillance System, satellites that don't take pictures, but instead listen passively for radar and radio signals from ships at sea. By comparing the microsecond timing differences of a signal arriving at multiple satellites in a cluster, the military can pinpoint the location of any transmitting vessel on Earth, without that ship ever knowing it's been found. The booster on that mission, B-1096, was flying its 7th mission and landed back at Cape Canaveral's Landing Zone 2, SpaceX's 642nd booster recovery overall. The sonic boom from its return woke up residents across 3 Florida counties. So to recap the week, Curiosity found a Martian mystery too big to explain with one theory. Roman Space Telescope is fueled, on schedule, and about to become the fastest survey instrument ever built. 3 astronauts came home after 241 days in orbit, and SpaceX kept up its relentless pace with a classified spy satellite and yet another Starlink batch. We'll be back next week.